My name is Paul Unger. I'm strategist for 5808 and 1678, as well as drive coach for 1678. And I'm also an app programmer on the team, so working with strategy and scouting.
Hey, I'm Brayton. I'm app programming lead, and I'm doing webcast at this competition.
So, essentially, first of all, what is a scouting system? So, it's a system that allows you to collect and analyze data and help you determine strategy. And so, if you actually want to make an effective scouting system, it has to actually accomplish all of these. If you make a scouting system, that cannot successfully analyze data, you don't want the scouting system, it's useless. If you make a scouting system that doesn't actually help your strategy, collecting data that's totally irrelevant, again, doesn't help your strategy, it's not a good scouting system. So, what we're going to be covering today is not just electronic scouting systems, but even kind of the theory behind pen, paper, whatever type of scouting system you're planning on doing. In the end, there might be a bit of stuff that's more specific to electronic, but overall, it'll be pretty theoretical. How do you design a scouting system?
And by the way, there's also a higher level presentation that you can get from that we did last night, and many of you weren't here for that, and we can get that to you as well.
Yeah. So, data collection is the foundation of a scouting system. Essentially what a scouting system really needs to do. You can't analyze data and you can't design your strategy around it if you don't actually collect any data. So that's definitely the best thing. The second thing is simplicity is often better in terms of this. When you're making your data collection system, your scouts are going to be in the stands all day. They're going to be very tired. They'll have 4 hours the night before, and they will all be falling asleep and distracted. The most important thing is that you make the data simple to collect. Especially since scouting can be stressful, you want, when they're scouting, they need to know, okay, that's definitely that. And so what we do on our team is most of the scouting we do, or most of the scouts we have, just collect very easy to count data. So for example, in 2014, one of the things that the normal scouts collected was just number of shots in the high goal. That's very easy to count, it's very obvious. When the scouts are doing it, it's really low stress and they can see it really easily. That's one really important thing about collection. Get the right data you need and make it easy to collect. So, the most important things about this. Your data needs to reflect what you end up needing in the strategy. If you're collecting totally irrelevant data, your scouts should not be there because it's not actually helping you. The most important thing is figuring out what data you want to collect. So, on 1678, after we release the game, if you go to the presentation tonight with Mike, you'll hear we all get together, we brainstorm. And after that, for like a week, we will meet in L21 a couple rooms over, and we just figure out what data we want to collect and figure out the map we want to run on it. And so it's really important before you even design your scouting system to know, or before you implement, to know exactly what data you need to do your strategy. So making sure your strategy people are also in on that discussion so that you know exactly what you need. And then secondly, make it simple so that you can collect consistent and accurate data. An inaccurate system is worse than no system at all, because you'll get wrong information, make the wrong decisions. It needs to be accurate, which is where simplicity comes in, making sure your scouts can actually do it. Optional, a highly intuitive UI. With enough scout training, you can get your scouts to do a lot of things, but it will make life easier for your scouts if you make an somewhat intuitive UI. But as I said, it's not necessary. If you just have a usable UI, you can train your scouts into doing it. So if you have less scout training, focus on the UI.
I'm sorry this picture wasn't as funny as we thought it was.
But we found it. So then the second part is analysis. So after you get your data, you actually have to analyze it. You don't want to go to your strategy lead and say, okay, here is like 50 pages of exactly everything the robot did in every match. They will not use that data, it's way too detailed for them. So you need to essentially condense all that data down into a couple numbers that they can glance at and go, okay, that's how good the team is at this one characteristic. And so this is really where the strategy part comes in, because you need to know, when doing this analysis, what characteristics you want to rate. And you have to figure out how those different pieces of data you collect fit into that. So for example, in 2014, another good example, we were looking at driver ability. And this was one thing that we looked at as an important thing in figuring out teams. It was hard to rate driver ability, and driver ability was divided into 4 categories: speed, torque, evasion, and blocking. And so what we needed to know was which of these is the most important to figure out driver variability. And weighting those, we use a lot of mathematical regression analysis to figure out how to weight the different aspects and figuring out how to optimize your calculations so that number really reflects what you want it to. Yeah, that's the main thing. So, critical things for the analysis part, it has to be strategically relevant. It has to really reflect what you're looking for in a robot. If you've got calculations that spit out numbers that you never use, again, it's not, this kind of system isn't adding anything. It should be understandable. When you hand it to the strategy lead, they should go, okay, that robot is really good at this immediately. They shouldn't have to, go through a bunch of question and answers trying to figure out, and a bunch of in their head analysis trying to figure out what this robot is good at. Should make strategy easier, not harder. Your numbers should supplement the strategy. They should not get in the way, mess with you guys. And when you're looking at those numbers, make sure you subject them to sanity check. Sometimes just do the way you design the calculation. A certain combination on a team you really don't want could end up getting a really good score. So don't just blindly follow the numbers. If you see a really good score on a team that you didn't know about, go check into them, but don't immediately go ahead and pick. Optional, real-time analysis is a really helpful thing. For pen and paper, it's essentially impossible, but it really helps with match strategy. So with the pen and paper system, a lot of it comes down to the night before the draft was designed, because that's when you have time to compile that data. Real-time analysis is really helpful in figuring out match strategy. So that way when I go around and I'm talking to teams, I can pull up, how is this team doing and see trends, how are they doing over the competition? Are they getting better, are they getting worse? Do they just have a bad match? Everything. So that is really helpful for determining match strategy. Flexibility, it's nice to have a flexible system at championships or at competition because maybe you want to change a calculation or something. Maybe you realize something went wrong or you want to add a new calculation or something. And so getting a flexible system that allows you to mess with stuff in the middle and also fix things or whatever you need to do is really helpful. And then adding complex equations. Your calculations and your analysis do not necessarily have to be really complicated. Just doing a basic averaging of how many stacks they put up in a match is perfectly fine. It gives you that good analysis. But for things like score prediction, which we do, they get a lot more complicated, but they can contribute a lot. It's just where your resources you want to put them at.
Okay. This is me. Yes, it is. Sorry. So, moving on, once you've analyzed your data, you need to see your data, and no, you don't want your strategists sifting through a database. That's not very fun. It also takes a really long time, and so it's not practical to use, during a strategy meeting. I sound like a broken record with this. Colin already said this, I think, twice, but don't let people visualize data. Don't let people see data that they don't need for their strategy meeting. It needs to be based on the analysis, based on what you decided was important. Okay. So simple. This sounds like, well, of course, I put the data in a simple way, but what is a simple way of viewing data is sometimes a question that takes more time to answer. It's going to require communicating with your strategy team. It's going to require thinking about, okay, so if I were trying to pick between robot A and robot B, and they both have this stat and this stat, and they're all the same, what do I need to see that's going to let me say immediately, I want them, or I want them? And sometimes that's literally a photo. Okay, and then it just has to, I mentioned this already, it has to keep up with the pace, because if you're looking through your entire database full of scouting data, you're not going to be able to keep up with the pace of an actual strategy discussion trying to go through 20, 30 some odd teams to decide what your entire pick list is. Okay, so this is another advantage of the electronic scouting system is it's possible for you to have it be available to anyone on your team. If you had, for instance, a Google Docs-based system, you might be able to have anyone log on and see all the data, or we have apps that we can download to Android or iOS devices, and so anyone on our team can come up to a programmer where you can plug their phone in and download the app, via cable, and they can see all of our scouting data. And then aesthetic appeal. Graphs are pretty. Enough said. So you could have really great data, but if this really great data is irrelevant to your strategists, then it's not really great data. If this really great data turns out to be wrong because your scouts were half asleep and they didn't know that they were supposed to be at the arena at 7 and they were there at 8 instead, logistics are important, and if you don't do them correctly, it could cause problems. So the critical aspects are, so first, communication. You need to talk to your team leads about where scouts need to be, when they need to be there. You need to talk to your team leads about how much technology can I buy? Can I buy tablets, or am I limited to using people's personal laptops and a Google form? And then you need to talk to your strategists about what data do you want to see, what data do you want to see first. And then you need to talk to your scouts and anyone else who uses an app about how they want to view data or how they want to input data. Because the best UI is not necessarily best UI in the opinion of the programmer or the opinion of your team captain. It's the best UI in the opinion of whoever's going to be using that app. That's it. Doesn't matter what other people think. Okay, so equipment, another one of those like supposed no-brainers, not a no-brainer. Losing equipment is not good. We've done it before, and I wouldn't recommend trying it because your captain and your team leaders and your mentors are generally not happy with you. Pretty sure you can probably agree with that, yeah.
Have we found the tablets from last year?
No. They were stolen. So assigning people to equipment is one strategy for not losing equipment. It's just like, okay, call in, keep the tablet bag, whoever, keep the laptop. That way you have sort of redundancies, like this programmer is in charge of this equipment, the programming lead is in charge of the equipment, the captain is in charge of the equipment, your mentors are probably also in charge of the equipment, and so you're much more less likely to lose it somewhere. Realize the limitations of scouts. This is especially a problem at champs or other events that get really intense. When you're trying to get to the arena really early and get really good seating, you either go into bed late because you had to do a strategy meeting or whatnot. The relationship between the amount of sleep scouts get and the quality of the data that they can provide, it goes like this. It's a direct relationship. And then programmers, you can't, if you have an electronic scouting system, you can't go to competition without programmers. Even if you think your electronic scouting system is really consistent and always works in the shop,
It is going to break.
it just is going to break during competition. So always bring at least one programmer, if not more, depending on how complex your system is, how much they know. Okay. So, what don't we want to do? Inaccuracy, we don't want to have inaccuracy, we don't want instability, and we don't want irrelevant data. I'm going to speed through this one because it's kind of the opposite of the first few slides. Go. Inaccuracy. This is Colin's quote. It has been said by pretty much every single person on this team since then. It's really, really true. Scouting error, when your scouts are tired, when your scouts are not paying attention or not focused, they will input bad data. When your scouts haven't scouted before, they may input bad data. And so you may ask, well, how do you fix that? They can't just get scout training and be great scouts the first time. Well, they can. You go and watch webcasts and you force them to all scout the same robot. And if they get exactly the same data 5 times in a row, then maybe they can go have a lunch break. But you can, watching webcasts is a really, really good way to make sure that your scouts are prepared before you go to competition. Calculation errors shouldn't happen. You should have a second programmer check your calculations or a second strategist, if it's a paper system, check your calculations. There's no reason for that to occur. And misunderstanding of calculations is actually surprisingly common. By this I mean, when your strategists don't understand how you're calculating data, you might say, okay, we're gonna rate driver ability. And so your strategist says, okay, well, you know, I think that they calculated that by every match they ranked the drivers 1 through 3 and divided by the number of matches, and so driver ability will be some, you know, some number between 1 and 3. And wait, no, guys, we don't calculate it that way. We actually calculate it the way Colin described, with these 3 different data points about, like, what was it, torque, speed, and evadation blocking, 4 different data points. And it's dangerous when your strategists start making assumptions that are incorrect. Okay. Instability. Brief note, yeah, it's the third-party beta software. We had an issue with some software being kind of annoying, and maybe this is a really obvious one that we shouldn't see, because unless you're really confident in it, don't use beta software. Thank you. And then for internet, competition will always have horrible internet. It will always be worse than you expect. You will drop connections, it will be slow. Even cell data is often really bad. So make sure that you run tests of your apps where you literally turn them like on airplane mode if you have apps, or if you're using laptops, you know, make sure you're able to turn off Wi-Fi, turn off all internet connection, and you're not gonna just lose data. You have to rely on data if you have electronic scouting to a certain extent in order to actually upload to a server or whatnot. But you want to make sure that when you don't have an internet connection, it caches it and it's not gone forever.
I would add one other thing too on this.
Sure.
Test your equipment, understand the limitations of your equipment. We had a problem 2 years ago. We installed a Raspberry Pi. We didn't understand, even though it has 8 ports, in fact, you can only use 7. We didn't realize that until we got to St. Louis. So we didn't understand the limitations of our equipment.
Yeah, I mean, same thing goes for if you're running it on, you know, if you're using a Google form, it might not be so great to like run that on someone's laptop using Arch Linux or something like that. Or if you're running an app on a phone, make sure you run it on the actual person's phone who will use it in competition, because otherwise you may have some unexpected problem with that device.
Also, one thing, before you pick a server company, with the server, we ended up getting a server that had like 30% uptime.
Yeah.
Doesn't help.
So this isn't to scare you away from third-party software, third-party services, because it would be really difficult to do any kind of programming or any kind of scouting system without them. But it just means to understand have contingency plans if you can. Okay, and then your elements, already went over it. Don't make your strategist like this guy. That's bad. And don't make your data or your calculations so complicated that when you explain it to them, they can't understand how you're calculating that piece of data, because that's not very useful either. All right. So that's going to be it for today for our formal presentation. Thank you guys very much. We still have plenty of time intentionally because we wanted to have a conversation more informally with you guys. So we can start with any questions about what we've covered here. Anything? It can be pretty.
The entire point of this was because everyone has different capabilities in terms of scouting systems. We would do the theory and then have you guys, if you have any practical questions at all, feel free to ask questions.
So, like reading your guys' white paper, and I don't know if other people are aware of that, you had that out there for what you guys did. Like you talked about your issues with Dropbox and your other database issues and stuff. So, how do you guys already discuss within your own team what your possible
It's no secret. I mean, like, so this year we're looking into Firebase. It's essentially a glorified JSON that syncs automatically between your devices. It fits really well into the category of functions offline because it captures the data super nicely and just syncs the JSON when you have internet. And it's very simple to use. Dropbox was one of those things that could potentially have been more elegant, but the API was a little more complex. it didn't handle, there were a few too many layers of abstraction, and so it ended up not. I mean, it was fine, but it wasn't great, and so we're going downscaling a little bit.
It's trying to pick third-party software that addresses what you're trying to do, and don't just like actually hack it together so that the third-party software that doesn't do what you're supposed to do ends up doing it, because it won't do it well. Sure.
Explain what JSON is.
JavaScript object notation is just like a database, except for I don't know how many people are programmers, but like, it's like a giant map or a giant dictionary. But it's a database that can fit you in a plain text file as well.
It's a way of easily transporting data.
Anything else?
Do you guys integrate with First API or Blue Lens API as far as match schedule and like ranking information and stuff? Or?
So all of our rankings, we go back and forth. I believe rankings were down at Chance, I believe it was. So one advantage of doing rankings on your own is we were the only ones that functioning rankings at that time. So that is one advantage, but I mean, if we want stuff, we want to get it from them because they're probably a little more reliable than the scouts. So the way to do that is we have, so at the end of every match, our scouts input the score that the alliance got, and so that way we keep track of scores. But the scouts, they're not perfectly accurate, so relying on Blue Alliance when it's available is good. And then if anyone hasn't noticed, First API started releasing a lot more data this year, like what they collect this year. So we may end up integrating with that in the future, but generally there will still be more stuff you want to look at than what the Blue Alliance.
Yeah, there was actually an issue that the first website at several weekends actually had difficulty putting data up.
Yeah.
Which then stopped Blue Alliance and FRC Spider from recording data. So there were times when we actually knew where the teams were in position because we had our own data. But other teams didn't know because they were relying on First to supply information.
Use it, but don't rely on it.
That happens with unfortunate frequency that it will be down.
Also, you can use the data in other ways. For example, for taking off our plane flight to go to Chance, we used Blue Alliance to download like 500 videos of different robots. So that's another way you can use those resources.
How many developers do you have on your team? What kind of experience do they have going into before you guys started with dry OS and perhaps?
So, interesting question. Most people come on to the team, join the team with no experience on either of those. Maybe 5-10% of our programmers have some programming experience in general when they join the team, but the vast majority of it is through like pure training.
So I'll tell you, I can't remember if you guys are on the team in 2013.
Talking about 13.
No, so in 2013 was the first year we started this system. We started with one person who's now a mentor on running the robotics programming, Donald Pinkney. He was the one who wrote the program. He was really into iOS programming. He didn't know hardly anything about Android programming. So he built the system in iOS first and then converted to Android. He was the only experienced programmer, and we had 3 other kids that worked on it. There was no mentor support for programming. Donald did all of it himself. I was overseeing it at a very high level, but I was not involved in the actual program. So he was able to piece it together as a student and lead these 3 other students to build the system.
And in terms of 2015, I believe we had like 4 people had experience in the team, and maybe like 4 people who didn't have or who were new on the team and might have been there for part of the season. So
This year we have like, I want to say 13, no more, like 17 programmers. So that's going to get split between app side and robot side. App tends to take a few more. So coming into the season, we will probably have like over 10 app programmers.
But one good thing to know is that you can make any type of scouting system. So even if you have no resources, you've got one person. If you follow up like the guidelines we talked about, you can make it decent, definitely pretty good paper scouting system with just one person and a couple of scouts.
Even an electronic one.
Yeah, and most teams actually have a surplus of programmers relative to the needs of the robot programming. And so it's actually a great way to recruit more programmers to your team because they can learn how to do the cool thing of doing app programming for for smartphones. This is basically what it's all about. They learn that skill of how to do it, so it becomes a useful recruiting tool for your team, that they're doing something else that you can soak up resources.
Yeah.
And like he said, we can use as many programmers on the app side as we get.
Yeah,
Because we can come up with new
the only
functions.
challenge becomes logistical at that point.
So we're going to do this year program more into our pit scouting device, which we started last year, make it more elaborate. And then we're going to do a strategy app
Yeah,
as
that's-
well,
that's
the electronic strategy
And
app.
replace our whiteboards with iPads.
Yes.
So, yeah, I mean, there's not really a limit to how many programs you can have. Also, app programming is really, really useful as a life skill. If anyone is interested in going into software engineering, robot programming is super cool, and it's definitely applicable, but like number of jobs wise, you probably have more and faster growing job opportunities for mobile side. So it's a great way to get more programs onto your team.
Yeah. And we've also forced the app team to learn both Android and iOS language. So they're able to switch between them, and they know about the compatibility between the two systems.
Yeah, because we have data viewing apps on both platforms.
Because I have an Android phone and Mike Mercado has an iPhone.
That's pretty much why it happens. Yes. So how many of you guys have a scouting system, electronic or not? Like, how many of your teams have any kind of scouting? Yeah. Like, does anybody who's not Citrus have an electronic scouting system or like a beta version of an electronic scouting system?
You have a beta.
You have a beta. But what's team number?
1671.
60. Oh yeah, I know. Okay. Anybody who doesn't have one interested in trying to create this coming season or the next one an electronic version?
Yeah.
It's been really key. I mean, Mike will vouch for us. It's been really key in strategy meetings. Richard did vouch for that as well. So yes. Sorry.
So on the design analysis side, you said you had 4 data points that you used to evaluate driver ability.
That was a couple of years ago.
As an example of that, right?
Yeah.
How do you come up with the equations or the weights placed on each component?
So
Yeah,
it depends. So for weights, we use regression analysis. Richard would know more about that if you want to talk to him.
Yeah, actually, I was just thinking about, we have a half an hour, and if we can pull up the presentation, I can go over some of the things that we worked through. So kind of going to a higher level of how we do
Is this the 10-minute math lecture now?
No, I won't get into that, but I will get into a little bit about the cool part. So just to sort of back up, our system, which is kind of unusual, is that we have 6 scouts who are counting quantitative stuff on the field: goals, stacks, cans,
Drawing this.
yeah, and keeping things that you can count. So that we have those, and we kind of rotate our scouts through. When we're here in Sacramento, we put 20 kids through running that scouting app, and they rotate through. Then what we have, what we call the super scouts. There's 2 of those, maybe 3. They're experienced kids, and what they do is they watch for qualitative information. They watch for driver ability, the blocking ability of the robot, the torque and power and speed of the robot. And they rank the robots. What we do is we do ordinal ranking in that case. We look at, one scout looks at the red alliance, the other scout looks at the blue alliance. They rank how well each one of those robots ranks from 1, 2, 3 in each of those categories. And then we do a weighting system. So what we found is by doing ordinal ranking, rather than trying to come up with some kind of quasi-relative ranking, instead of giving, oh, that team's 4.5 and that team's 4.6. Instead of trying to do it that way, we found that this ordinal ranking actually works reasonably well when you have 10 matches to work with.
Presentation.
Yeah.
So you rank 1, 2, 3 based off of the 3 robots that are on the field. So
Right, and then we assume the transitive property. If A is better than B and B is better than C, then A is better than C. And so we assume that holds over the long time. And then what we found is when we look at the end, that the robots, the top third robots really are, they look like the top third to us, the middle third, bottom third. So, and without really getting into, well, is this team better than that team sort of thing. But that's close enough for us.
One thing to be aware of though is just for calculation in general, it depends on the game. 2014, a lot of interaction between teams becomes a lot harder to just evaluate, so we use a lot more weights. 2015, because it's such a solo, like, I make a stack game, you can do a lot more based on point values and stuff. So some of the calculations really depend on the year.
Yeah. So actually, let's just. I'm going to just go quickly through, since many of you weren't able to make the talk last night. We do money bots, is what we call it. So we got Steve Harvey instead of Brad Pitt as our guru. So just quickly going through it, just go. So we have principles of money bots where we're combining quantitative and qualitative analysis, and it comes from sabermetrics, which is from baseball. Let me just flip through this real quick. Baseball, it does statistical analysis out the wazoo. The Oakland A's had a great winning record in the early 2000s. Low salary, the lowest salary base in baseball, and one of the best winning records because they did statistical analysis. So we can go through this. I'm not going to talk about the difference between baseball and robotics. You know about that. You're looking at different strategies, different things. One of the keys is looking at roles of robots. So, for example, 2013, we got full court shooters, and there were cyclers that were out there. We were a ground pickup. We would pick up the frisbees and put them in. So if we had a full court shooter that missed, we were there to pick up the frisbee. 2014, we played as a midfielder, so we looked for inbounders and finishers, scorers at the end. So, and then this year we were doing landfill with human player pickup. So 2018 was great for us because there were landfill. So anyways, next slide. You want to know the game rules inside and out. Know, for example, we had to know when an assist was. That was very important. And know what strategies won't work because they're illegal. Next one. Consider lots of ways of scoring. So for example, we figured out early on that grabbing cans out of the middle was the key to winning the world championship. And that's what we focused on. We went through 3 iterations of our can grabbers. And we also went through installing can grabbers on a second robot through 3 competitions before we got to the Worlds. No other team did that as much as we did, and it mattered. So you think about defense. Defensive points count as much as offensive points. You're reducing points, and you think about ways of trying to prevent scores. We were actually playing defense this year. We were stealing cans from other teams. You're looking for the most effective ways of scoring points. So in 2012, co-opetition points were really important for tiebreakers. This year, there was what's the tiebreaker was? Co-opetition points again, right? So actually at Chesney Champs, we won the tiebreaker because we were the only team that did co-opetition at all in the whole competition.
Like 2 matches with competition.
Yes. 2014, we had the most assists of any team out there because that's what it was a tiebreaker. Next one. You're looking for difficulties of points scored. So like in 2014, assists and trust shooting were a really easy way to score points. Hitting high 10-point goals was a real difficult way. So we said, we're not doing 10-point goals. We're doing assists and trust shots. And that's what we focused on. And then we focused on preventing 10 points as well.
This is the 10 for 10, save a penny kind of.
Right.
So that way.
So then there's other things you have to worry about, abstract counting. So for example, there's things in 2014 when you had assist points that you couldn't count assist points that occurred on the field. You had to figure out a way of saying what leads to assist points, and that was possessions and passing. So we would count possessions and we would count passing, and then after we went through the competition, we figured out how much those assists and passing were worth. It turned out they were worth about 5 points. Every time you possessed the ball and passed it, on average it was worth about 5 points. So we used that as a weight in our scoring, but we would count passing and count assists in our scouting system and then figure out what the weights were. So then going through which numbers we have.
We'll just skip this. I'm going to skip this part about OPR and contribution to win margin. It's useful for knowing OPR, for going in and predicting scores and before the competition, but it's not really that important for looking at this.
OPR is kind of like a numerical representation of how much they contribute to an alliance. It has to do with that, but adding up all of their scores ever and who they were playing with, etc.
Yeah. So in terms of our statistics, I'm actually not even gonna, they've already covered most of this about the ordinal ranking. Quantitative scoring is what our scouts get. Qualitative is what our super scouts get. We're looking for driver ability. We're looking for speed, torque, and defense. We look for blocking ability. That's actually one of our key defensive statistics. In the quantitative attributes, we break out auto score, teleop, and the end game when there is an end game. Could be an interesting end game this year. Yeah, we count things like balls blocked in 2014. We convert, as I talked about, the abstract values into discrete values. So we figured out a way to convert passing and possessions into assists. Next one. So then we do the qualitative scoring. We do driver ability. As I said, we talked about ordinal ranking. We rank within an alliance from 1 to 3. And then often what we do is if we will pick the best robot on the field between the two alliances and give them a 4 in some cases. And then, I lost one. Go back. So then we also talk about evasions. The way we do driver ability, the thing that we focus on mostly is evasions. Then we look at drive speed and traction. You're the first mechanism robot that we've ever picked. We'll probably never pick another one again. And then looking at blocking, blocking being their ability to pass through the field. So these are all attributes that we look for when we're doing our scouting system. They've been pretty robust that we've looked over. In 2013 and 2014, this is the kind of system that we had. It was not so important this year. And then, as I said about ordinal ranking, we're looking for that transitive property. If A is better than B, B is better than C, then A is better than C. That's math for you, and that's what we assume. And you're quantifying the qualities, and so this gets to your question about how we do the weightings of those various things. So how much are these values really worth? And so we go through a kind of a multi-step process. The first competition is, I have to admit, our first regional is usually a guess as to what we think defense and driver ability is worth. And sometimes we're able to use previous year's data because, in fact, teams have kind of a correlation. Their OPRs are actually pretty well correlated from one year to the next. And then what we do is, like, for example, week 1 results, we do pre-scouting, which Colin might talk about, where we do scout training, and we use week 1 or week 0 competitions and do the scouting to test our scouting system, train our scouts, and then we can download the data, actually, in some cases, to try to figure out some weights to put on some of these abilities. And then the other thing, if you go back, the other thing is that we compare our draft list, our final draft list from the previous competition to our scouting data. And we run a regression against it to say, oh yeah, what was our scouting system, or what was our draft in the end, and what did our scouting system say? How do we have to move robots up and down our quantitative draft list in order to make it match better with our qualitative draft list? What we ultimately end up with. And then we're looking for weights to match various preferred qualities. Next one. So what we do is we derive the defensive value by looking at, we have predicted offensive scores for the robots from our scouting data. So our scouting data, we can go, oh yeah, we predicted that they would score 200 points in this match, but they only scored 180. Why did they deviate down to 20 points? And we look to the opposing alliance in a particular match and say, okay, what are the qualities that were, the driving qualities that were in that other team that might have explained why the robot, they scored 20 less points than what they should have been predicted as scoring in our scouting data. And what you can do is actually minimize, yeah, so we use a minimized squared error on the predicted match scores using Solver. And so we use goal seek in that, and we put weights on the 4 different attributes, and we use solver to minimize the mean squared error on the predicted scores versus the actual scores. And by just running it, and you do it iteratively back and forth in order to go across with solver in order to do that. And you can do multiple changes in solver.
All these calculations and stuff you guys are doing on the server side.
And actually, no, we do this post-competition. Yeah, I do it in an Excel spreadsheet. I have to get it regular enough that I can get the kids to do it. So I just refined it enough. It turned out, unfortunately, this year we didn't really need to do it. So that process got kind of stopped. But eventually, this year, if we have another game where there's interaction between teams, I want the kids to run this analysis.
Waste times are very important this year. If you want to look at our math, feel free to just ask me. There might be one way, I can't even remember if there's one.
Yeah.
All of the code is available on GitHub. The technical explanation of the scanning system is available on Sheet. Like everything is very open.
Except for the calculations, which are talking about that.
And if you guys do it on calculation server side, I'm assuming that when you transfer that data, pull it down.
Yeah.
Already been calculated.
And then we estimate the updated weights, and then again, we go back to what our final draft list was in the previous competition and compare it to what our predicted draft list would be just using quantitative and qualitative data. And then we combine these into meaningful values, and the thing is that these breakouts are for our different attributes of our robots. We're looking for 2 different roles in our robots, which I'll talk about in a minute, but we're basically, one part we're looking for is offense, which you're all probably in your scouting systems where you have them. This is what you're basically looking for. So like in 2014, it was what you scored in the auto routine, your goals that you scored, the trust and catch, and then possessions of the ball that you had that led to assist points. So we would do that kind of scoring, and that's really your number 1 pick. This is what you're looking for in that kind of thing. And then when you're looking at your number 2 pick, what we do is we look at 2 things, which is the driver ability that I talked about, the qualitative scores, because we want a defensive robot. And the second thing is value added. That is, how many points can they score with actually directly in teleop going and scoring goals? So what we're doing here is, for example, in 2014, it was possessions, because that would give you 10 or 20 points, depending on how many possessions you had. This driver ability down here, which was the defense, because that becomes basically you're gaining points against the other alliance, and ball control, which also went to this possessions part. In 2013, which is actually more interesting, you could score auto points and then never score another point during the rest of the match. Then you had the end game, which was the pyramid, and that was another independent action that didn't really rely on the other teams. And then you had this driver ability, which was about our defensive attributes. But these are things that we were adding into our analysis. We were looking for it. I think in 2013, there were a couple cases where we picked robots for their auto routine, even though their defense wasn't quite as good. And hardware and software, go ahead and see if there's, skip through this. This is what Colin just finished and Brighton just finished talking about. And then add the competition, training and organizing. So we train and organize our scouts at least 1 week before the first competition. We bring them in for a training session where we watch week 0, week 1 competitions, and we find the bugs in our system. And we do a lot of various other attributes of doing score prediction, pre-match strategy sheets, which many of you might do, but we just implemented that in the last couple of years, and it's the last 2 years have been very useful, kind of strategy sheets.
We covered that.
Yeah, we covered all of it.
That's technical and things.
Yeah. Going through that, prediction. Let me skip over that. Oh, actually, one thing, how many of you are aware that there is a database of past results, all the regional results up on the web?
I saw the master set up.
Yeah. How many of you have looked at 2834's database for on match results? One person. How many of you are on Sheep Delphi? How many of you know what Sheep Delphi is?
It's pretty good.
Okay, you need to be on Sheep Delphi. because there's a bunch of stuff that comes up on that. It's a bulletin board where there's a lot of discussions about robotics. Our team is very active on there. We find out all sorts of inside information. We get all sorts of tips from Chief Delphi. I really urge you to get on Chief Delphi and follow what the discussions are. That there's a Team 2834 Ed Law. He puts up a database that counts all of the scores for all the teams from all the regionals. And it's a tremendous database for knowing when you're going into a regional, you can look at that and project, oh, I'm facing some good teams or I'm facing some weak teams. And you can actually use that database to predict scores for some of your matches before you get to the site. And so you can figure out your strategy beforehand.
And just so you know, all of our Chief Delphi is also where all of our white papers are.
Right, if you want our white papers, you have to join Chief Delphi. Let me see, then we use our data in real time for match planning that I talked about. The best thing about pushing data to your drive team, the most important thing is when you're in a match strategy discussion and you're trying to say, should you run your auto routine? And the other team says, we hit our auto routine every single time. We have the most awesome auto routine. And you can look at your match data and say, you know, actually you only hit it 2 out of the last 5 times. You're not running your auto routine because our data says that you're not going to run your auto routine. So that becomes really important in your discussions. We call it our BS sniffer. So that's probably the most important thing. You're also able to identify on the other side of the field who are the strongest teams in this, that are going in this competition right now. And you're able to focus your defensive strategies. Pit scouting, we started doing that this year a lot more on the pit scouting. Our cheesecake, which we're kind of limited for. We actually went out in 2014 and we measured the inbounding speed of robots at both Silicon Valley and at championships. We had a timer and we went around to 50 teams at World Championships and ran the ball through the robots to see how quickly they could inbound. And then in 2012, we were measuring other robots to see if they had the right dimension in order to balance things.
Richard, can you be done like a couple minutes?
Yep, I think so.
Like a couple minutes now.
Let's see, draft night, compile all of the material. Just know about game out your the possible seating order. We wanted to know who we were facing this year in the can races. We do different scenarios for pick lists. We have a pick list for our first robot and a pick list for our second robot. And they can look quite a bit different to each other. And then what we do is we compile a single list 1 through 25 from that list. And usually there's a break point around 10 or 12 in terms of the robots. Usually the offensive robots are usually picked in the first 10 or 12 robots. Looking for robots that best complement your strategy, ones that they're reliable, consistent, and are versatile. Those are the main attributes we're looking for in robots. Excellent. And then our second pick robot, we're looking to fill various gaps. It's unlikely that they're going to be scoring any points, so we're looking for defensive roles, for value added, that value added calculation that I talked about. There's different things that each of these robots could do in different years depending on the game. And then this one is our favorite one is make sure when you're done with your draft list that you destroy all your other draft lists. Because we actually had a case in 2013 that a team walked out with the wrong draft list and started drafting off that list. And their first pick was not the robot they actually wanted. Whoops. And so then that's just basically, we're perfecting the list in the morning. We do our draft list the night before, but then we go back and we work with it during the last couple matches during the day. And then this one, this is just the story of things that we did with our draft list. And that's, don't need that, don't need that. With a couple of improvements that we're going to be looking at for doing things on the robot. Lessons learned.
Grain dinner.
What's that?
Grain
dinner. So we gave up, for a couple of years, we kept on having our draft list, night draft list, where we would eat dinner for an hour or two and then go back to the hotel, and we would always go to bed after midnight. And we just went, okay, done with this. So we started, the scouting strategy team goes off separately, and we bring in dinner to the hotel for the draft list. and then do it after. And this is the tagline to the movie Moneyball. Yeah, Moneyball.
Yeah.
Right, Moneyball is the movie. And so this character was the guy who brought statistics and regression analysis to the A's. And so this is just the line out of the movie where he's getting things down to one number. Using the stats the way we read them, we'll find value in players that no one else can see. And our experience in that's been true, that we've been in situations where we've just looked at the teams that were left on the table when they rolled around, and 1671 is the best illustration of that. There's no way that they should have been left on the table for us to pick as the 24th slot at the championships. There's just no way. But we got them, and once we got them, we actually pretty well knew we were going to win the division. Really? Yeah, we were pretty sure we were going to win the division. Once we had them, and we were going to Einstein at that point. So that was, and our experience is actually in 2013 and 2014, the same thing happened. Our second robot that we got should have been a first pick robot for another team. So doing this kind of thinking through the strategy and that sort of thing, and how you apply that to your scouting system is really important. That's it. So I have
one more quick thing, or a couple more quick things about the numbers. And this isn't always the solution for getting numbers, but one way that you can sometimes often quantify things is the probability that something happens times the number of points. And we use this for column. What would you say? What percentage of our calculations were
So last year, less this year, like 90%.
Probably, because this game was really simplistic strategy wise, but this year probably hit 90% we were doing this. And the probability being how many times they've done it over the number of matches they've played. So that's you were asking about how to get some of those numbers. This is the simplest one to get. Okay, so we're gonna have 2 minutes left. So any more questions before we get?
now that we packed a lot more information.
Two presentations, one.
Yeah.
A couple things. First of all, if you want to see the scouting system, we've got a couple of examples of it up here. You can see the viewing app and the Android app. You can probably also see the server, but it's not really that interesting. Yeah,
Code is interesting.
yeah, code is interesting. And then, as I said, if you want the math, I don't think we've actually open sourced that yet, but I have no issues giving it to you. So just let me know. That's all.
That's right. Get to it.
Yeah.
All right.
So I do want to say one other thing too. For many of the teams that don't have draft, that don't have scouting systems yet, and you might think, oh, we're never going to be actually ever in a position to pick in the top slot or anything like that. The fact is that if you have a scouting system and you're a first pick robot, you bring value to your alliance. That there's a case actually in Sacramento in 2013 that we got picked by 1662 because they knew what Mike said was the coach of 1662. He had seen our scouting app at Central Valley. He saw that we had great scouting information. And so that if he didn't pick us, he knew that we were going to pick an alliance that was going to be able to beat his alliance. So he picked us instead, but there were mechanical issues that kind of screwed us up, and we didn't do as well as we wanted, but anyway, that was, the thing is that if you have a scouting system, you come in with good information, and you tell the team that we can pick your second robot for you, that will make you more attractive to a top alliance captain.